Okay, this one is nicer. This is number 8. You have this this Q equation, which stands for production level, and K is the level of capital, and L is the labor. Oompa Loompas. So here's your the equation we're going to look to maximize this production equation, and the constraint is capital costs $1 per unit, and labor costs $3. Think of it per unit or per people's salary. And Willy Wonka only has $64 in his account. So that constraint then is 1 times K plus, how much did I say the L was per unit, plus 3L equals 64. That's your constraint. Okay, so then let's jump right to, we want to maximize this production. So we're going to do the Lagrange equation. So it's going to be the original equation minus lambda times the constraint, at least the variable relationship here. The 64 comes into play later, as we've seen. Okay, so then, and if we want to distribute this piece, it's just minus lambda k plus 3, not plus, got to distribute by negative, minus 3 lambda L. Okay, so that's just, maybe I'll just write the whole thing again, 4k to the 1/4, L to the 3/4. All right, now let's do the partial derivative with respect to k, which means L we think of as a constant. So the fourth's going to come down using the power rule, and 4 times a fourth is just 1. So, and just think of L as 3/4 as a constant. So, and then k, you have to subtract 1 from the exponent. So 1/4 minus 1, or 1/4 minus 4/4 is negative 3/4. And then the derivative of minus lambda k is just going to be minus lambda. Okay. And then the partial derivative with respect to L. This means k is now a constant. All right, bring down the 3/4, which cancels with that 4. So it's just 3k to the 1/4. Remember, k is just a constant. L, 3/4 minus 1 is 3/4 minus 4/4, or negative 1/4. And then minus 3 lambda. Okay, you're going to set each of these equal to 0. So if I look at the top equation I have, and if I solve it for lambda, I've got lambda equals L to the 3/4, oh, excuse me, k to the negative 3/4. In the second equation, I've got 3 lambda equals 3k to the 1/4, L to the negative 1/4. But the 3's can cancel. All right, so they're both equaling lambda, so let's set them equal to each other. And I'm actually going to bring the negative things with negative exponents to the denominator. So the left equation is L to the 3/4 over k to the negative 3/4. Oh, becomes positive. That was the whole point. When I bring it to the denominator, that negative exponent becomes positive, equals, the other lambda was k to the 1/4, and this time L goes to the bottom to make the positive exponent. So if I multiply across here, notice I get L to the 3/4 times L to the 1/4. Same base, you add exponents, so it'd be L to the 4/4, or just L. And then when I multiply across k to the 3/4, again, adding exponents, it's k to the 4/4, or just k. So it looks like for the optimal or critical point, it's when L equals k. So let's go back to our constraint equation, which was the following. We've got k plus 3L equals 64. Well, k is just L, so let's just plug that in. So L plus 3L equals 64. 4L is 64. So L is 16, and we said L equals k, so that means k also is 16. Okay, so it looks like the optimal, what was that, Q, is when, so let's do Q 16, 16, and let's see what we get. When I plug in, so 4, 16 to the 1/4, we're plugging it back into the original, this production equation, and then 16 to the 3/4. Okay, so remember with fractional exponents, the numerator means the power it's raised to. The denominator is the root. The fourth root of 16 is just 2, so 4 times 2. I always try to do the root first if possible. We just said the fourth root of 16 was 2, so in this piece you'd have 2, and then to the third power is 8. So then we have 8 times 8 is 64. So it looks like the maximum production level would be 64 when both, when labor was 16 and capital was 16. Trying to think if, I mean, it doesn't in this case make sense. Remember, we talk about extremes, like if it doesn't make sense putting 0 for one and seeing what the other is, because the original equation here is the variables multiplied together. So if one of them is 0, you're just going to get 0. So it's not going to be one of the extremes when one of the variables is 0 and the other is whatever it is based on the constraint. That doesn't make sense here because, again, if one of the variables is 0, then the whole thing's 0. So because it's just multiplied together, so that doesn't make sense. So the only possibility was when both are 16 and that max production level was 64. Okay, that was 8.